Hello again, this is Professor Jim Caffey, based in Springfield, Missouri, and we are going to go over Chapter 21 today in the OpenStax Astronomy free textbook. Chapter 21 is on the birth of stars and the discovery of planets outside the solar system. Here is a beautiful Hubble Space Telescope image of the Carina Nebula. This is in the southern hemisphere down by the southern pole. So we can't see it in the northern hemisphere, but what a beautiful picture of star birth going on. This one of the most famous pictures ever taken by Hubble. I remember this. I was at the meeting where it was announced, and it was pretty dramatic. Here we see what has been dubbed the Pillars of Creation, also known as M16. This gas cloud is a star-forming region, baby stars being born up there at the top. You need gas, you need dust to make stars. Here is my favorite constellation, Orion, seen in the winter, seen visible, how you see it in the sky, and in the infrared, and you can see the heat signatures. Again, the Orion Nebula, shown in visible on the left, a little bit of infrared on the right. I just can't find anything more beautiful in the sky than the Orion Nebula. Now, here is a really key piece that I am an expert on. The central region of the Orion Nebula. We see there are really 6 stars in here. Some of these stars are double stars. Some of them are eclipsing binary stars, which is what I study. And I did some work in the 1990s on the Orion Nebula. What's hard for someone like me to work on this is I have to have a blank sky. I just need a star or two and a dark blank sky so that I can do photometry and gather light. Unfortunately, with the Orion Nebula, you have all this bright gas and dust, which makes studying these stars very tough. But I was able to do that in the 1990s and had a number of publications from it, and pretty neat stuff. I haven't seen too many people repeat what I had accomplished with a small scope. Another beautiful star birthing region from Hubble. How do you get star formation? Well, like I said, you have to have gas, you have to have some dust, cloud, a molecular cloud, and you need a shock. You need something to ram up against that cloud and shock it and clump it together before you start getting things forming. So we have a cloud, and this cloud starts to rotate and shrink like a skater would do with their arms. And we form a star this way. Here are some gas jets, really neat stuff, forming from a protostar, a soon-to-be star, a baby star. And this is the neighborhood around it from Hubble, and we call this, it's got a great name, HH34. We call these Herbig-Haro objects. Pretty neat. Here are more outflows of that gas and dust from protostars. Disks around protostars, where I said we have that disk flatten down and spin around to form a dust disk. We've seen that with Hubble, and we have seen that around different observatories. And really beautiful stuff there. Now, protostars stop being a protostar and turn into a regular star, a main sequence star, depending on its age and its mass and temperature. And when it becomes a main sequence star, we put it on this graph that says 0. I think my dog is hungry. I left food out. Oh boy. 0 age main sequence. So when it hits the main sequence, we say it's started its life. Started its life. More disks around protostars. When you live with dogs, this is what happens. More protoplanetary disks around stars. a dust ring around the young star. We can also detect planets with the Doppler method. We can see stars going near us and apart from us, and a planet is going to make a very slight wobble in that orbit. Now, this is very timely here in 2019. As I'm recording this, Planet Discoverers 1995, Taylor Clives and Michael Maillard at the Geneva Observatory. They were the first to discover a planet around a regular star, 51 Pegasi. And it just so happens that these guys won the Nobel Prize along with one other fellow in 2019 for that discovery. We see a lot of hot Jupiters, hot massive planets. We can see planets going around other stars and they go in front and cause a transit. We have seen that with Venus going around the Sun. The Kepler spacecraft has been in orbit for a number of years. It is running out of fuel and it is really on life support right now, but it has detected hundreds of thousands of variable stars. It's done seismology on stars, shock waves. I have a colleague from Missouri State University who is a principal investigator on Kepler and looks at helioseismology and star quakes.
Sorry, I'm not sure.
We can see exoplanets around stars. These are soon to be planets forming. And here are all the exoplanets discovered through 2015. So it's a lot. What you should get out of this is it's a lot. And they do form a grouping here. So a lot. And Kepler has discovered many planets. And that's really what is up there for it. Now this exoplanet is pretty interesting, Kepler 62, and there are zones, habitable zones, that life could, if it existed, could be there. There are many like Earth planets. We are looking for them and finding them with more technology. That does it for chapter 21. Thank you for joining me and my hungry dogs. They are hungry for my pizza. See you next time.